Hello, welcome back. We're going to be beginning lesson 10.4b today, the second half, to ellipses. Today our goal is going to be to write the equation of an ellipse given certain characteristics. Let's take a look at our first example. While we take a look at our first example, I want to remind you that you can look back at your notes from 10.4a, which helps to remind you of all the different characteristics of an ellipse. Let's take a look at example 1. Example 1, we are beginning with a center of -1, 2, a major axis that has a length of 12 and is parallel to the y-axis, and a minor axis which has a length of 6. It's important to know that whenever we're finding the equation of ellipse, there are three things that we need to have in order to write the equation. We need to know the center, our A and B values. After that, we're pretty set to go. Let's take a look at the information they gave us and see what it looks like on a graph. First of all, I'm going to plot the center at -1, 2. I get this red dot that appears on my graph. So far we've already got the center, so we're a third of the way done. The next piece of information that they gave us is that the major axis has a length of 12 and is parallel to the y-axis. So there's two important bits of information in that. First of all, the major axis has a length of 12. Remember, the major axis is the bigger of the two axes. This will deal with our A value. Secondly, this description of parallel to the y-axis is going to help us to determine if this is a horizontal or vertical ellipse. Remember, parallel to the y-axis means it runs alongside it. So here's our y-axis right here. Our major axis is going to be parallel to it and have a length of 12. Remember, the major axis goes through the center and is split evenly. So if our major axis is 12, from the center to each vertex is going to be 6. Let's draw in our major axis. You can see here that we have our yellow line, which from tip to tip is 12 units long. So from the center to the vertices is 6 units. This is an important piece of information. Remember, this unit right here, which is 6, is going to help us because it is our A value. Remember, A is the distance from the center to the vertex. So we've got two of our three things so far. We've got our center and we've got our A. Now let's look at our B. Well, remember, if your major axis is going vertically, then your minor axis has to go the other direction. So our minor axis has a length of 6. It's going to run through the center again, and it's going to be 6 units from tip to tip, which means when I draw it in, I get this green line, which is 6 units across, which means 3 in each direction. And we get our last piece of pertinent information, which is our B value. My B value, remember, runs from the center to a covertex, and here we can see from the center to the covertex has a value of 3. So what do we have so far? We've got a center at -1, 2, an A value, remember that's always going to be the bigger one, of 6, and a B value, which is the smaller, the distance from the center to the covertex, of 3. Lastly, we're just going to put it into our standard equation of ellipse. First of all, you should always remember that an ellipse is always set equal to 1. The x's always go first, and then the y's. The last thing we have to put in is the information we got from our drawing. If the center is at -1, 2, remember we put the opposite. So here's my x coordinate. I'm going to take the opposite of -1, which is +1. Here's my y coordinate. I'm going to take the opposite of +2, which is -2. And lastly, we need to consider one more thing. Is this a vertical ellipse or a horizontal ellipse? You can tell this by kind of drawing in the picture. And you can see that this is a tall ellipse, in which case it has a vertical major axis, which we can see with the yellow, and therefore my A value, the larger value, is going to go under the y. Remember, this is your A squared. So in other words, this is going to be 6 squared. The bigger number is going under the y once again because this is a vertical major axis, which means my b value of 3 is going to go under my x. The last thing I need to do is just square my 3 and my 6, and I get my final answer of x plus 1 squared all over 9 plus y minus 2 squared all over 36 equal to 1. Let's try another example when we're given different characteristics. Alright, with example 2 we're given 3 little bits of information. We're told that the vertex is at 8, 3, and that we have a covertex at 2, 1 and a covertex at 2, 5. So let's go ahead and once again use a graph to help us to visualize what's going on here. So the first thing I'm going to do is draw in my vertex. Remember that vertex is going to have to deal with my A value. So far I've only got one vertex that's drawn in yellow on my graph at 8, 3. They provided me with 2 different covertices. The first covertex is at 2, 1, and the second covertex is at 2, 5. So we have a picture something like this going on. We need to visualize what's really going to happen here when we draw in this ellipse. Remember that the covertices are connected by the minor axis. The vertices are going to be connected by the major axis. Where the major and minor axis intersect will be our center of our ellipse. The center, remember, is an important value we need, as well as our A and our B values. So the first thing I'm going to do is I'm going to just draw in my minor axis. Now, how do I know that this is my minor axis? Once again, remember the minor axis connects the covertices. The other thing we're going to try to do is draw in my major axis. Well, right now there's a problem. The only vertex that I have is here at 8, 3. But you should remember that it is symmetric. Therefore, however far it is from the minor axis to the right, it should also be the same distance to the left. So, visualizing this, look at where the vertex and the minor axis would meet. They would meet right here. They are 1, 2, 3, 4, 5, 6 units apart, meaning that the other vertex would be 6 units to the left. 1, 2, 3, 4, 5, 6. So here's a little visual of what's going on in my picture. I've found my center now because it's where the major and minor axis meet. So my center is at the coordinate 2, 3. My A value, which remember is the bigger of the 2 values, runs from my center to my vertex. So my A value here is from this center coordinate to this vertex, which we already discovered was 6 units apart. Lastly, my B value is from the center to the covertex. So my B value here is 2. Lastly, we need to determine, is this a horizontal or vertical ellipse? I can draw it in kind of to see it a little bit better, although you should have been able to identify it with that major axis. And you should see that this is a wider ellipse, meaning that it is going to have a horizontal major axis, as we can see demonstrated in the picture here. So let's go ahead and write our equation. Remember, your x's always go first, then your y's, and it's always equal to 1. So in this problem, my center was at 2, 3. So I'm going to put the opposite in the parentheses. Opposite of 2 is negative 2. Opposite of 3 is negative 3. Lastly, we figured out that this was a horizontal ellipse. Because this is horizontal, I'm going to put my A value under my x. My A value is 6, and remember I'm going to square that. That leaves my B value of 2 to go under my y. Square our denominators, and we get our final answer of x minus 2 squared all over 36 plus y minus 3 squared all over 4 equal to 1. All right, let's move on to our final example that we're going to do together. And this is example 3. Example 3, we are given the foci at negative 2, 2 and negative 2, 4. We've been given our vertices at negative 2, 5 and negative 2, negative 7. Let's go ahead and plot these. All right, so our first foci is at negative 2, 2. I'm going to go ahead and plot that. And my other foci was at negative 2, negative 4. So I've got my two orange X's there representing the foci of my ellipse. The next thing I was given is my vertices at negative 2, 5 and negative 2, negative 7. I'm going to plot those. So right now let's analyze what we've been given. I can see that my foci and my vertices are on a vertical line, meaning this is going to be a vertical ellipse. So already off the bat, I know that the larger denominator is going to be under the y value. Remember, we need to find our three things: our center, our A, and our B. This example is going to be a little bit more challenging than the other two, but still very simple to get to the final answer. So first of all, let's talk about finding that center. Now you should remember that the center lies, ironically enough, in the center of everything. So whether I consider the center of the foci or the center of the vertices, the center lies smack dab in the middle. So let's look at it from the view of the foci. I've got a foci here at negative 2, 2 and a foci at negative 2, negative 4. How far apart are these foci? Well, they're 1, 2, 3, 4, 5, 6 units apart, which means that my center is in the middle of that. So the center will be 3 units away from each of the foci. So my center is at negative 2, negative 1. Our A value, remember, comes from the distance from this center to my vertices. So from my center to this vertex right here, how many units apart is that? 1, 2, 3, 4, 5, 6. Which means that my A value here is 6. Now my B value is where it's going to get a little trickier in this example. My B value is the distance from the center to the covertices. But was I provided any information on the covertices in this example? No. Was there any allusion to the length of the minor axis? No. So we're going to have to go about finding B in a different way. And I want to remind you of one of the very important characteristics of an ellipse, which is that c squared equals a squared minus b squared. We'll remember that c value is the distance from the center to the foci, the a value is the distance from the center to the vertices, and the b value is the distance from the center to the covertices. Well, in this problem, you need 2 out of the 3 things to move forward. And fortunately, I do have 2. So let's look at what we have. The c value being the distance from the center to the foci. I've got the center, I've got the foci. Let's see how far apart they are. They are 1, 2, 3 units apart. So my c value here is 3. So I'm going to plug a 3 in for c. My a value we already determined to be 6. Remember, that's the distance from the center to the vertices. So my a value here is 6. My b value is what I'm searching for, so it's going to stay exactly the way it is in the formula. 3 squared makes 9. 6 squared is 36. And now we're going to solve it like a normal equation. I'm taking away 36 from both sides. I get negative 27 is negative b squared, which remember just means that b squared is equal to 27. And lastly, to get b by itself, I'm going to take the square root. So I get b to be the square root of 27. And normally we're going to go ahead and do our factor tree or put it in simplest radical form. But you're going to see that we don't need to actually do this when we're writing the equation of an ellipse. And you'll see why in just a second. So now I've got my center at -2, -1, my A is at 6, and my B is the square root of 27. We already determined that this is a vertical ellipse because the vertices and the foci run along a vertical line. So this is a vertical ellipse, which means that my A value is going to go under my Y. So let's set up our formula. You remember your X's go first, your Y's go second, and it's always equal to 1. So in this problem, my center was -2, -1. So I'm going to put the opposite in the parentheses. And then lastly, remember my A value of 6 is going to go under my Y because this is a major axis that runs vertical. So I'm going to put my 6 squared here, which means that my B is going to go under my X. So I'm going to get the square root of 27 squared. And now you'll understand why I didn't go ahead and go through the hassle of simplifying that square root of 27. I end up with x plus 2 squared all over the square root of 27 squared is just 27, which works out nicely, plus y plus 1 squared all over 36 equal to 1. Always 1 with an ellipse. So remember, in this example, we use this very, very special formula, c squared equals a squared minus b squared, to help us find missing information. In other examples, you might have to find the a value in order to figure this information out. But just keep in mind that this is a very important formula that comes in handy whenever you get stuck. Remember, the center, the A, and the B are the 3 things that you need. So we're going to go ahead and have you try a problem. I want you to try to write the equation of an ellipse with foci at -4 and 6, 0, and covertices at 1, 7 and 1, -7. Hit the pause button and then we'll check to see if you got the correct answer. Alright, let's check your answer. We ended up with x minus 1 quantity squared all over 74 plus y squared all over 49 equal to 1. Check your calculations over here on the side. We used the given information to find out that c was equal to 5 and that b was equal to 7. We used our interesting equation of c squared equals a squared minus b squared to help us find our a value, which was the square root of 74. It was a horizontal ellipse, so the bigger value of 74 ended up under the x value. If you have any questions, feel free to ask about them tomorrow in class. So let's go ahead and we're going to wrap this up. What we want to remember today is we are working backwards to find the equation of the ellipse. All of those properties we studied in the first half of lesson 10.4 hold true. Remembering that the center is always where the major and minor axis intersect. And c squared equals a squared minus b squared is a frequently used formula to help us find one of our missing values. Thanks for stopping by, and I hope you have some good notes from this and we can have some conversations tomorrow. Have a good day.